3. Atlas could be a regular comet that's just acting a little stranger than usual. Or it could be something else entirely, perhaps even an alien vessel of some kind. What exactly is 3I Atlas doing out there? And why is it injecting something called an unnatural seed into interstellar space? Some scientists have suggested that objects like 3I Atlas might be jump-starting the birth of planets, specifically gas giants like Jupiter. Astrophysicist Suzanne Falsner has proposed a theory rooted in the standard model of planet formation known as accretion, which posits that tiny particles stick together and gradually grow into larger bodies, eventually forming planets. In Falsner's view, planets are born from the bottom up. Dust grains suspended in a protoplanetary disk slowly clump together, forming pebbles, then rocks, and ultimately full-sized planets. But she takes it one step further. What if the universe was seeded, but by travelers? And what if one of them, 3I Atlas, is doing exactly that? While some theories, like those from Harvard's Avi Loeb, venture into more speculative territory, Falsner's idea might be more grounded than it seems at first glance. In her theory, 3I, Atlas, and other space rocks like it could be the dry yeast that brings life to otherwise lifeless dough, in this case, early planetary systems. Her models suggest that stars more massive than our Sun are especially good at capturing these interstellar visitors. Recently, Loeb co-authored a paper suggesting that 3I Atlas might not behave exactly like a typical comet. He pointed to anomalies in its trajectory, brightness, and the timing of observable gas emissions. Loeb even proposes, though tentatively, that it could be a form of alien technology or a disguised artifact. In my recent essays, I suggested a Loeb scale for interstellar objects, where 0 is a definitely natural object, like a comet or asteroid, and 10 is a definitely technological one. Currently, I give 3I Atlas a 6 on that scale. But my assessment could change as we gather more data when it comes closer to the Sun. Is 3I Atlas a comet or a message from the stars? Astrophysicist Avi Loeb, known for his provocative ideas, is asking the questions most scientists won't. He's not claiming that 3I Atlas is definitively an alien spacecraft, but he's urging us to consider the possibility. Why? Because the consequences of ignoring such a clue could be cosmic in scale. The discovery of an extraterrestrial artifact, Loeb writes, would reset our priorities to explore real estate beyond Earth instead of fighting over borders on it. What if the first spacecraft from another civilization doesn't announce itself with flashing lights and dramatic landings? Scientists' most puzzling features of 3I Atlas is an unexpected green glow detected as it sped through our solar system. This isn't the typical dusty coma of a comet reflecting sunlight. It's a vivid green hue, often associated with specific gases like cyanogen or diatomic carbon, common in comets, but not always so brightly or consistently visible. Avi Loeb has proposed that the green glow might be an artificial signature, a kind of beacon or waste emission from advanced technology. If 3I Atlas is indeed a disguised alien probe or vessel, the green glow might be its fingerprint evidence that we are witnessing the first physical trace of extraterrestrial visitors in our cosmic neighborhood. This interstellar object is racing into our solar system at nearly 60 kilometers per second. Now, within 2 astronomical units of the Sun, it's suddenly brightening far faster than models predicted, is expanding rapidly, and recent NASA telescope images show it glowing a surprising green, likely from diatomic carbon gas. Even stranger, parts of its coma appear to stretch toward the Sun, unlike typical comet tails. It will make a close pass by Mars, where orbiters will scan its brightness and nucleus size. But by October 21st, 3I Atlas slips behind the Sun in superior conjunction, making it nearly impossible to observe from Earth. This is only the third interstellar visitor ever recorded, after Oumuamua and Borisov, and it behaves differently. Whether it's just an exotic comet or something entirely new, its rapid changes are challenging what we know about objects from beyond our solar system. The mysterious interstellar object traveling through our solar system has been spotted acting like no other comet ever seen before, revealing its alien origins. Michigan scientists announced that they have uncovered new images of the object dubbed 3I, Atlas, which were taken months before its official discovery in early July. NASA scientists believe this means the mystery comet could be filled with a unique collection of molecules, including carbon monoxide, an odorless gas often produced by burning wood or fossil fuels. Adina Feinstein, a leading researcher in the study of interstellar objects, highlighted the unique scientific opportunity presented by 3I Atlas. It gives us an opportunity to study other solar systems up close and personal without actually needing to visit them. Unlike distant stars and planets that require powerful telescopes and indirect observation, 3I Atlas serve as natural messengers, carrying clues about the chemistry, dynamics, and even possible life-bearing materials from other parts of our galaxy. Researchers used old images from NASA's. The TESS images were taken between May 7th and June 2nd. TESS, originally designed to find planets around other stars, takes wide pictures of the sky. They realized that 3I Atlas's current path lined up with the same plane the planets in the solar system travel along, making it possible for researchers to go back to look for the approaching comet. In those re-examined pictures, the object appeared brighter than expected, suggesting it might have been releasing gases into space several months ago. The unusual characteristics of this object might be explained by the fact that it originated in our solar system formed under very different conditions than our own. While the comets that orbit our Sun are mostly made of water ice, 3I Atlas appears to contain a higher proportion of carbon-based ices. These carbon-rich ices can vaporize and produce gas emissions even at much colder temperatures than water ice. This suggests that the building blocks of planets and comets in its home system may have formed in a distinct way, possibly influenced by the type of star it orbited or the unique cosmic environment surrounding that system. Such differences could provide valuable clues about the diversity of planetary formation processes throughout our galaxy. Learning about other solar systems places humanity into context, Feinstein said. Is 3I Atlas actually a galaxy-hopping planet seed? The idea is that certain interstellar objects might act like cosmic gardeners, carrying the raw materials needed to jumpstart planet formation far from their home systems. Instead of planets forming solely from dust and gas slowly clumping together, these seeds could deliver crucial building blocks, like carbon-rich ices or organic compounds, into otherwise barren protoplanetary disks around young stars. If 3I Atlas is one such seed, it would mean that life's ingredients, or even planetary systems themselves, could be intentionally spread across the galaxy, hitchhiking between stars. This concept opens up profound questions about whether advanced civilizations might be deliberately seeding life. With its unusual composition rich in carbon-based ices and its peculiar behavior, fits the profile of such a planet seed. Unlike comets in our solar system, primarily made of water ice, 3I Atlas's ices can sublimate at much colder temperatures, suggesting it formed in a radically different environment. This hints at a home system with unique conditions, perhaps orbiting a star, unlike our Sun, or situated in a distinct cosmic neighborhood. The galaxy-hopping planet seed hypothesis suggests that objects like 3I Atlas may serve as carriers of life-essential compounds, organic molecules, or even microbial life itself. A concept tied closely to panspermia, the idea that life can travel between star systems. If true, this means the universe might not be a random collection of isolated systems, but rather a connected web of life's dissemination, with seeds traveling like cosmic spores to fertilize nascent planets. Could this process be natural? The result of random gravitational ejections and interstellar drift? Objects like 3I Atlas is whether their journey across the galaxy is a result of natural cosmic events or something more deliberate. Astrophysics provides a plausible natural mechanism. During the formation and evolution of planetary systems, countless small bodies, asteroids, and comets. This gravitational ejection can sling these objects out of their home systems, sending them on long, lonely voyages through interstellar space. What similarities and differences in composition and behavior have scientists observed between Oumuamua and 3I Atlas? We only know of 3 ISOs because we've only been able to detect them for a short period of time. The first one, Oumuamua, was discovered in 2017, and in the 8 years since then, we've found 2 more. Looking back over the solar system's roughly 5 billion year age, it's easy to see how large numbers of ISOs have likely traveled through our solar system. Falzner's research sheds light on a puzzling aspect of exoplanet science: why Jupiter-sized gas giants are uncommon around smaller stars, but appear more frequently around stars similar to our Sun. The challenge lies in the limited lifespan of the planet-forming disks surrounding these stars. Around Sun-like stars, the disks of gas and dust that give rise to planets don't last very long. Within roughly 2 million years, powerful stellar winds and radiation start to erode and disperse these disks. By the time stars reach about 10 million years old, observations show that their protoplanetary disks have usually vanished completely. This means that giant planets have a very narrow window, just a few million years, to form before the essential material disappears. In cosmic terms, that's a remarkably brief period for such massive planets to come into existence. What is the mystery of Oumuamua? Interstellar objects were predicted to exist long before Oumuamua was discovered. However, Oumuamua wasn't what astronomers were expecting. Small and unusually shaped, it didn't look like a comet. The leading theories involve the sublimation of either nitrogen or hydrogen ice. There is no evidence that Oumuamua was a spaceship. As the first interstellar visitor to have been identified, Oumuamua gives us insight into what other extrasolar planetary systems might be like. How have the discoveries of Oumuamua and 3I Atlas influenced our understanding of interstellar objects entering our solar system? When the 3I Atlas appeared, it added another layer of complexity. Unlike Oumuamua, 3I Atlas displayed comet-like activity, but with puzzling variations in brightness and gas emissions, including a mysterious green glow. Its composition, trajectory, and behavior suggested that interstellar objects are more diverse than previously thought, ranging from rocky, possibly artificial objects, to active, volatile-rich bodies. These discoveries have expanded scientific curiosity and prompted the development of new observation strategies and theoretical models. They underscore the importance of watching the skies for these fleeting visitors, as each carries unique information about the conditions and processes in other star systems. The presence of such objects also raises profound questions about the possibility of life or advanced civilizations elsewhere in the galaxy. Oumuamua and 3I Atlas have opened a new chapter in astronomy. Loeb argues that while natural explanations cannot be ruled out, the anomalies exhibited by Oumuamua merit serious scientific investigation into artificial origins. Loeb has called for more rigorous observation of interstellar objects in the future to better understand these possibilities. When it comes to 3I Atlas, Loeb has also entertained the idea that it could be more than just a typical comet. Oumuamua and 3I Atlas are windows into the material and dynamics of other star systems, offering rare glimpses of the universe beyond our own solar system. Scientists said over the coming months, space telescopes like Hubble and JWST will be able to zoom in on 3I Atlas to probe these and other questions about its size, spin, and how it reacts to being heated. We have these images of 3I Atlas where it's not entirely clear, and it looks fuzzier than the other stars in the same image, said James Ray, a professor at the Georgia Institute of Technology who was involved in the discovery. The object is pretty far away, and so we just don't know. As 3I Atlas turns out, it may be observations from Mars, not Earth, that give us our closest look at the comet. 3I Atlas will come as close as around 30 million kilometers to Mars, while it will only come within 270 million kilometers of Earth. That means spacecraft orbiting Mars are in play. We can confirm that we are planning to observe 3I Atlas around the time of its closest approach to Mars, Wilson said. This is predicted to occur on the 3rd of October 2025. On this date, the object will still be approximately 30 million kilometers from Mars. What do we know about 3I Atlas? 3I Atlas. Everything you need to know about the new interstellar visitor shooting through the solar system. Scientists initially assumed that the 3I Atlas was an asteroid. However, in subsequent observations, the object looks more similar to a comet. The interloper has displayed tentative signs of cometary activity, including being surrounded by a bright cloud of gas and ice, known as a coma, and having what looks like a tail, according to the International Astronomical Union's Minor Planet Center. 3I Atlas is different from its predecessors due to its size, although it's hard to measure its size right now. Astor Taylor, a graduate student at the University of Michigan and co-author of the new study, told Live Science in an email, "Is it possible to send a spacecraft to 3I Atlas? In the vast darkness between the stars, strange visitors occasionally pass through the solar system, objects not born from our sun, but from other distant worlds. In 2017, we detected the first of these known interstellar objects, Oumuamua. It was unlike anything we'd ever seen. Then, in 2019, came 2I Borisov, a more familiar comet-like object. And now we have the 3I Atlas, discovered in 2023. Researchers had previously proposed similar missions for Oumuamua, as well as for future ISOs. But this is unlikely for 3I Atlas. It may be possible theoretically, but we don't have any missions prepared that could do this, so we won't be able to," Taylor said. How many interstellar visitors could we see? It took another 6 years for the next interstellar visitor. But Jewett said that recent calculations show that the solar system could have a lot more visitors from beyond, a lot more. The best estimate of the density is one of those guys every 10 cubic astronomical units of space. A U is the distance between the Earth and the Sun. So that means that at any one time there should be about 10,000 closer to the Sun than Neptune, he said. But he adds that the calculation could still be off by a factor of 10, highlighting just how uncertain our current estimates are. What's exciting and what could help refine those numbers is the recent addition of the Vera C. Rubin Observatory in Chile. This powerful new telescope is designed to scan the entire sky every few nights, dramatically increasing our chances of spotting fast-moving or rare interstellar objects. With its sweeping and regular observations, it could lead to the discovery of many more of these cosmic interlopers. Even more importantly, detecting them earlier would give scientists more time to study them as they pass through our solar system, unlocking valuable data about their origin, composition, and trajectory. They take about 10 years to cross the solar system from one side to the other, so that means There are 1,000 coming in per year and 1,000 going out per year in steady state. It's going to come a lot closer to Mars than to Earth, such that one of the Mars cameras that I have been using for over 20 years since the start of grad school will, in this case, get better resolution than Hubble next month, scientists said. A daring ESA mission will attempt to rendezvous with an unexplored visitor from beyond our solar system. A daring ESA mission called 3I Atlas is being designed to intercept and study unexplored visitors from beyond our solar system, interstellar objects traveling through our cosmic neighborhood. Unlike previous observations from Earth-based telescopes, 3I Atlas aims to actually catch up with these fast-moving travelers and perform close-up investigations. The mission will use advanced tracking technology and onboard instruments to analyze the object's composition, structure, and trajectory in real time. By doing so, scientists hope to uncover clues about the formation of other star systems and the materials that exist in interstellar space. This mission represents a major leap forward in space exploration, offering the first chance to directly study fragments of other solar systems and deepen our understanding of the galaxy's vast, mysterious environment.